Welcome to the Black Hole Archives. Today, the Fuzzball Theory. A radical idea that replaces the singularity with something far stranger. There's a radical new idea in physics that turns everything we know about black holes upside down. A theory that says, inside a black hole, there is no inside, no singularity, no point of infinite density, just a cosmic tangle of strings vibrating at the edge of reality. This is the Fuzzball Theory, a mind-bending alternative to the traditional picture of black holes. For decades, physicists believed black holes contained a singularity, a region where matter collapses into an infinitely tiny point. This idea created a major problem, the information paradox, because if matter, and the information inside it, falls into a singularity and disappears, that violates the fundamental laws of quantum mechanics. Quantum physics says, information can never be destroyed. But classical relativity says, black holes destroy everything. Both can't be right at the same time. This is where the fuzzball theory enters the story. According to string theory, all matter in the universe is made of tiny vibrating strings. When enough mass collapses under gravity, these strings don't form a singularity. Instead, they spread out, they stretch, they tangle, they weave together into a giant complex ball of quantum strings. This tangled structure is called a fuzzball. Imagine a black hole, but instead of a smooth event horizon around empty space, the entire interior is filled with a dense, chaotic, vibrating cosmic web. The surface of the fuzzball is the black hole. There is no empty region inside. Here's the amazing part. If a black hole is a fuzzball, then information isn't lost. It doesn't fall into a void. It gets stored in the tangled structure of strings making up the fuzzball itself. Hawking radiation, the slow evaporation of black holes, is actually carrying this information back out, bit by bit. So quantum mechanics stays intact. General relativity stays intact, and the universe doesn't break its own rules. What happens? When you fall into a fuzzball, the classical picture says, you cross the event horizon, you feel nothing, then you fall toward the singularity. But in fuzzball theory, you never enter a smooth interior, because there is no interior. You hit the fuzzball's surface, a tangled quantum storm, and your information becomes part of the structure. No inside, no singularity, no infinite point, just an incredibly dense quantum object. It's a completely different vision of what black holes truly are. Fuzzball theory isn't fringe. It comes from leading researchers in string theory and quantum gravity. The reason it's taken seriously is simple. It makes the math work. Traditional black hole models can't reconcile relativity and quantum physics. Fuzzballs can. It's one of the only frameworks we have that gives a consistent, testable explanation for the information paradox, black hole entropy, Hawking radiation, the structure of quantum spacetime, no singularity needed. If fuzzballs are real, then black holes are not holes at all. They're objects, exotic, quantum, string-filled stars. And that means something even more shocking. The universe might be full of fuzzballs, remnants of massive stars, each holding enormous amounts of information, encoded in patterns we barely understand. Some physicists even speculate that the fabric of spacetime itself might emerge from structures similar to fuzzballs. If true, black holes aren't the end of physics. They're the beginning. Fuzzball theory may sound strange, but so did black holes themselves when Einstein first proposed them. One thing is clear. The deeper we look into black holes, the less they behave like the simple monsters we once imagined, and the more they look like the key to understanding the universe. This is Infinite Narratives. Subscribe for more cosmic mysteries.